In a computer system, the address bus is a set of parallel electrical conductors that are used to transmit memory addresses between the central processing unit, CPU, and main memory. The address bus is used to specify the location in memory where data should be read from or written to. The width of the address bus, measured in bits, determines the amount of memory that the system can address. A wider address bus can address more memory than a narrower one. When the CPU wants to read or write data from memory, it sends the memory address to be accessed on the address bus. The memory address is then decoded by the memory controller, which uses it to determine the location of the data in memory. The memory controller then sends the data on the data bus back to the CPU or stores the data that the CPU has sent to memory. The address bus is typically unidirectional, which means that addresses can only travel in one direction along the bus. This is to ensure that addresses are only read by the memory controller and not accidentally overwritten by another component. However, some systems use a bidirectional address bus, which allows addresses to be transmitted in both directions. The width of the address bus is determined by the amount of memory that the system requires. In modern computers, the address bus width is typically between 32 and 64 bits, allowing the computer to address up to 4 GB or 16 EB respectively. In summary, the address bus is an essential component of the computer system that enables the CPU to access memory locations and enables the memory controller to locate the data in memory. It is a vital part of the system's architecture, and its width has a direct impact on the system's overall memory capacity.